Hello. I am so excited about today's talk. So Glen Gawarkiewicz is a physical oceanographer, but I think one of the most successful physical oceanographers in talking across boundaries. So he works a lot with the fishing industry. He's recently been working with offshore wind. Really, I think, skilled at sort of having conversations across disciplinary boundaries. And I think there's a lot to learn from him. He has a bachelor's from MIT and did his PhD at University of Delaware. And he's been at WHOI for the last few decades. And he is going to talk today about some variability in our Mid-Atlantic Bight Northeast region, which I think is really relevant to a lot of the classes that students are taking right now. So I think this is a really exciting seminar. So thank you, Glen, for being here, and kick it off.
Thank you so much, Jack. It's a real pleasure to be here. And I have a lot of material to cover, so I'll just jump right into it there. And so just first of all, to introduce myself and my research interests. Let's see. What's the best way to advance it?
So if you want to use the clicker,
Yeah.
you're just gonna hit.
Oh,
this
okay,
button.
so it's just the advance.
Or you could. Hold on. Sorry, Glenn.
Oh, no. It's
Okay,
me.
see if it's working
It
now.
really is me.
There you go.
Okay.
Move the mouse.
It's because it's right in the middle
Oh, sorry.
Yep, perfect.
Sorry, take two.
Oh, okay. So just to introduce myself, this is actually what I wore to my most recent talk in the buoy lunch there. This talk was on imaginary islands. And this picture is mostly to remind me to say that I'm a member of the Squid Squad. And Jack mentioned the different boundaries. Every Friday morning at 10 a.m., I actually talk with a group of about 20 to 30 people from industry, from the National Marine Fisheries Service, and from academia. And another kind of unusual turn in my career near the end is that I've actually also gotten very interested in old maps, especially from the 1500s and 1600s. And that's actually a map I have of the North Atlantic from 1580 there. And it does have a whole bunch of imaginary islands on it, which is what I talked about at Halloween this year, hence the costume there. But it also has sea monsters on it. And I will say that my most recent sea monster talk was actually at the Plymouth Foundation, which is a technology innovator hub. So I was kind of surprised that they asked me to talk about that, but that was a fun talk. Yes. And I primarily study shelfbreak processes. I'll show a cartoon in a minute, but just a quick outline of the talk. I'll just give a quick overview of the regional circulation and hydrography. Many of you probably are familiar with that. And I'll just mention recent trends because I'm going to contrast that with some of the changes in processes. A big part of my research now is cooperative research, and I work really closely with the commercial fishing industry, particularly the Commercial Fisheries Research Foundation in Rhode Island there. It's been 12 years that I've been working closely with them. And as you'll see, they have fishing vessels regularly going out and taking CTD profiles. So the talk is really in two parts. So the first one is about our first attempt to do three-dimensional mapping of a mid-depth salinity maximum intrusion, and I'll explain what that is. And the larger point here is that in the past 10 to 15 years, there's been substantially more exchange at the shelf break, with lots more warm core ring and continental slope water getting onto the continental shelf, and that's had a lot of ecological consequences. And then the ocean will immediately contradict me by having the cold fresh pulse of 2023, 2024, in which there were none of these intrusions there. And I think it provides a really interesting contrast to think about the favorable conditions for different species in the ecosystem, which again, because I hear about the fishing on a weekly basis, it's just been fascinating, all the contrasts. So in terms of the regional circulation, there's two major current systems, the Gulf Stream, the Western Boundary Current. there, and that's been known about for a long time. Western boundary current carries significant amounts of heat northward, part of the AMOC system. But there's another current that's also really important, which is the shelfbreak jet, and that comes down from the Labrador Sea, basically, and it actually terminates at Cape Hatteras, where the shelf water actually subducts into the Gulf Stream and becomes the ford water there. The shelfbreak jet tends to be very unstable, and you can get lots of meanders and eddies forming from it there. The main form of interaction between the Gulf Stream and the continental shelf is the passage of warm core rings. And those are large anticyclonic clockwise eddies that form from Gulf Stream meanders and then drift to the west. And when they come to the edge of the continental shelf there, they interact with the shelf water, and in the upper right of the leftward panel plan view there, you can see a shelf streamer of water coming offshore. And those are very significant ecologically. They tend to concentrate marine life. In the two panels on the right-hand side are climatological summer temperature and salinity cross-shelf sections. And there's a water mass called the cold pool that is very important there. That's tracked very closely by the National Marine Fisheries Service. That's a refuge for cold water fish there. And at the shelf break front at the edge of the continental shelf, which is the edge of the shelf water there, there's about normally a 4 to 6 degrees C temperature difference there with the continental waters of the continental slope. And then in terms of salinity, there's a coincident salinity gradient with the temperature gradient in the front, and typical salinity differences are 2 practical salinity units there. So this cartoon kind of summarizes my entire career. So I'm always careful not to delete it there. And one of the things that I did as a postdoc at Woods Hole was actually to look at idealized models of the front. And you can see the schematic with the ice attacks there for the shelf break jet. The shelf break jet is typically about 50 meters deep there. And it's very significant ecologically because there is bottom boundary layer convergence in the front that drives an upwelling. And typical rates are 10 to 20 meters a day there, but it can get up to 100 meters a day in the vicinity of warm core rings there. The thing that I've been really studying for about the last probably 6 to 8 years are the intrusions that come in from offshore. And I'll be talking about the mid-depth salinity maximum intrusion there. And I do want to say Charlie Flagg did some excellent work on these processes back in the mid-90s there. And then also, I won't talk about it today, but there's also bottom intrusions that can go up to 100 kilometers shoreward of the shelf break front there. An important thing to keep in mind, I mentioned that warm core rings interact with the continental shelf. The rings are typically 500 to 1,000 meters thick there, and so they can't get on the continental shelf, but what they can do is come close to the shelf and affect the shelf break jet. Okay, so I mentioned that I was going to talk about recent trends. The really surprising thing to me over, let's see, about the last 10 years is how active the Gulf Stream has been. And I work very closely with a colleague, Magdalena Andres, who is a real Western boundary current person. I'm a shelf person at heart. I talk to Western boundary current people, but anyways, she had a really nice paper in 2016. And it was actually inspired by a fisherman from Rhode Island, Fred Matera. We had a conference in late 2013 in which we had 4 fishermen talk about what they had been seeing in terms of changes. And we had about 30 scientists there. And the number one thing Fred Matera said was, we're seeing more Gulf Stream water on the continental shelf. We're seeing more sargassum. Well, lo and behold, Magdalena looked at the altimeter data there, and you can see in the left panels the panel A, 1995, the Gulf Stream is really relatively straight. By 2014, you can see the envelope of the north wall of the Gulf Stream is, to use an adjective that Magdalene has popularized, wigglier there. And following up on that, I actually have been working very closely with Avijit Gangopillai and his students at the University of Massachusetts, Dartmouth. And he had a master's student who actually did a climatology of warm core rings. I said to Avijit, if it's wigglier, I bet there's more rings. And we had a paper in 2019 that showed that the number of warm core rings formed took a step jump in the year 2000. It jumped from 18 to 33 warm core rings. And this is based on Jennifer Clark analysis charts. And so this is one of the reasons that the Gulf Stream has been much more active in terms of interacting with the continental shelf. Okay, so now cooperative research. I was involved with the National Science Foundation Ocean Observatories Initiative Pioneer Right. I actually led the team that did the initial design of it, although I was never a formal part of it after that point there. As a result of the permitting process, I went to a number of public hearings there that actually devolved into a shouting match. And so we had to have 4 multi-use conflict meetings that were refereed by a staffer from Senator Whitehouse's office. 4 4-hour sessions, really brutal there. And I'll never forget, she said, I'm from Senator Whitehouse's office, but I'm reporting back to every federal legislative office in the Northeast. So both sides be on good behavior. And we were. And it took 2 meetings, but we got over the trust barrier with the fishing community there. And about 3 months after the conclusion of the negotiations, there was an opportunity for funding with the MacArthur Foundation and for climate adaptation. So we wrote a proposal for fishing vessels to take CTD profiles. So we've been doing this since late 2014. So that's 10 years now. I believe the number is up to around 930 at this point there. And I'll show a time series that'll be important for the second part of my talk. And we use the RBR Concerto. The big technical advancement that allowed us to do this was the wireless capability, because the fishermen don't have to plug wires in. When it comes up on the deck, it talks right to an iPad on the bridge there. Amazingly enough, fishermen now use the profiles to decide where and when to fish. With 10 years of interaction, we've taught them how to interpret CTD profiles. They now know about the shelf break exchange processes, and they are making go, no-go decision based on what they see with those profiles. I could not have imagined that when we started the whole thing. The other thing is the dialogue is just as important as the data. And so twice a year, I go to the Commercial Fisheries Center and I give what I think will be a 20-minute talk to the fishing community, and it normally goes 2 hours. So we have had just some remarkable conversations there. The only trick is you really want bad weather when you schedule them so that they're not out fishing. So when it's like sunny and beautiful out, it's like, oh no. Okay, so now I want to talk about salinity maximum intrusion. So these have been known about for a long time, I think, going all the way back to the 1930s at the time of Bigelow, but they're normally identified in individual CTD profiles taken across the continental shelf. And so this is actually a real profile, but I'm using it as a kind of a schematic here to define how Steve Lentz characterized these intrusions. So he has a wonderful climatology paper from 2003. And so this is depth right here, then that's salinity on the x-axis. And in these profiles, there's normally a maximum in the middle of the water column. And it's usually higher than any other value in the water column there. So it has to come from offshore there. And the variables that Steve defined are S max, which is the maximum salinity of intrusion, delta S, which is the difference with the ambient salinity, the thickness, depth at which the profile is taken there. And so he did a lot of statistics on that. So in the early days of the pandemic, in that blissful time period before the whole world discovered Zoom and figured that you could fill an entire day with Zoom meetings, I actually spent a lot of time in my daughter's bedroom looking over 5 years of these profiles there. And so I actually went through 621 profiles, looked through every one and defined all those characteristics from it. And this is just a plan view of those profiles, and the black dots are profiles with no intrusions, and the kind of greenish there are profiles that do have a salinity maximum intrusion. And I just want to point out that some of them are located well north of the shelf break there. They're really going on shore. And in Steve's paper, he did say that some of these intrusions could get far on shore. But we noticed that on average that this onshore penetration was much greater in the 2015-2019 time period there. The big surprise for me, and this was a paper published 2 years ago, was when you looked at the frequency in terms of the percentage of profiles in a given month. So I averaged over 5 years. Steve took all historic profiles before 2000. I only used the Shelf Fleet area, which is just south of New England. It's pretty much between Montauk Point and Martha's Vineyard there. But the red line is the frequency there from those Shelf Fleet profiles. And you can see that in August and September, it's getting up to nearly half the profiles had the intrusions there. It was a 70% overall increase during this stratified season relative to the lens climatology there. And it's a little bit apples and oranges. I'm looking at a smaller geographic region. Steve covered all the way from Cape Hatteras to Georges Bank, but we repeated all the calculations with all the Ecomont data, and I collaborated with Paula Fratantoni on this, and we came up with very similar statistics within 1%. Okay, so that was done actually in preparation for a cruise to actually map one of these salinity max intrusions there. So we formed a team. So it was UMass Dartmouth, Avijit Gangopillai, and the ring tie-in with Musgrave at Dalhousie there, and Sam Kelly and Erica Green from the University of Minnesota Large Lakes Observatory. And every step of the way, we were talking with Paula Fratantoni and Anna Mercer there at NEFSC there. We did a cruise on the Neil Armstrong from June 18 to July 22nd. I've got a list of all the participants there. We had an onshore team. And I also want to say, we actually looked at Shelf Fleet profiles before we went out. So we got a little bit of an inkling of where intrusions might be there. And every day of the cruise, Susan Inglis from the Commercial Fisheries Research Foundation was sending tweets out to 300 people in the Rhode Island fishing community. So all the fishing fleet was actually seeing what we were doing day by day there. It was really just very rewarding to have that close of interaction. So my sleepless nights before the cruise were, how do we find these things when they're at 30 meters depth? And so, I spent a lot of time thinking about real fancy, what kind of a pattern should we do if we can't find something? And so luckily the ocean really cooperated with us on this one. They really get an assist. It turns out that there was a warm core ring directly offshore. And on the northern edge of the warm water, you can see these incredible wave-like features right there. So it was very obvious to go just a little bit to the west of that meander crest right there. And so we just did a cross-shelf CTD line to start the cruise out there, did 9 CTD profiles there. This is just the overall sampling during the cruise. We covered a big area there. And these are the nine profiles here. It turns out 5 of the 9 profiles did have salinity maximum intrusions. And I should add, our criteria for the intrusions, because there's all sorts of wiggles, was that the delta S had to be greater than 0.2 PSU. And you can see, let's say in that middle one, 0.005, there's actually 3 different intrusions that reach that criteria there. And just look at how different the shape of each of these profiles are. You know, it's just remarkable how complex, you know, and 3-dimensional all these features really are there. And that was one of the findings, by the way, even from the shelf fleet data, is that I think we had 10% of the profiles had multiple intrusions in them. And I think in Ecomon, it was even as high as 20% there, which has implication, I think, for prey fields. Okay, so we had several fun toys on the cruise, and one of them was the long-range AUV, which is a Tethys class vehicle from that was developed at the Monterey Bay Aquarium Research Institute there. And Amy Kukulia led her cybotics lab for that component. And one of the fun things was we could just put the vehicle out right after we finished the CTD line, and we just did a big box right there. So this is a visualization of the temperature on the left and the salinity field on the right there. And you can see at mid-depth there's just a beautiful SMAX intrusion. It's going, and that's that red there at mid-depth. That went 33 kilometers shoreward of the actual shelf break front there. And you can see on the offshore edge near the bottom, there's also that red for the high salinity. That's the foot of the shelf break front right there. So we actually went across the front right there. So we were very happy about that. So another toy that we had, and it was just a real joy to use this, was a Rockland 250 vertical microstructure profiler. And I won't be showing any of the mixing results here, but the temperature and salinity data, of course, was just very high resolution. And so this is a cross-shelf section on June 20 right here. And the bars there indicate the vertical extent of a delta S of 0.2 right there. So you can see that it's 20, anywhere from about 15 to 20 meters thick right there. There's a pretty sharp onshore edge to it right there. And in the middle panel, the 34.0 isohaline is plotted in red. And it's overlain on the color of how strong the Brent-Weissel of the buoyancy frequency is right there. And one of the surprises to us was that the peak in stratification was actually much shallower offshore than over the continental shelf. And there was a theory in the 1980s by Frank Aikman about how these intrusions might form, where the main hypothesis was that the mixed layers were deeper on the offshore side, and then the mismatched depths led to a reversal of density gradients. We saw the exact opposite conditions in terms of the stratification. And I believe that was because of the presence of the warm core ring. It was more stratified offshore than it was onshore, which is, again, kind of unusual. And one of the biggest questions for me was just is the along shelf scale of these kind of features there? And so another toy we had to play with was a Remus 100 autonomous underwater vehicle. And so this is a section right here, and the middle panel is the salinity right there. And all of the vertical profiles are plotted on the right there. So you can see that huge increase at mid-depth there in the intrusion. So it turned out to be 14 kilometers there in a long shelf extent there. So they're not, gigantic there. They're kind of in that sub-mesoscale to small mesoscale. Someone probably has an acronym for that, but I don't know what it is. And then just the final thing in terms of our toys that were out there. So it's just wonderful to work with engineers who say, hey, I just finished the software yesterday morning, and this is the day of the departure. we can now actually autonomously track salinity. Want to try it? So after we recovered the vehicle from doing the rectangle there, we actually put it into frontal tracking mode, and we were able to move along the boundary of it. And there was a paper published in 2022 about this. The important thing from this, and this just indicates how the algorithm worked to go across, and we just had different salinity thresholds. But the thing that was really interesting was we were able, because we went back and forth over, I think it was 10 days there, to actually see that this intrusion became pretty quasi-stationary in terms of cross-shelf movement. So we saw it in a very mature phase. It wasn't in an active pushing offshore, pushing on shore phase. And I should add, in our second cruise, which I'm not going to talk about today, it was moving on shore 25 centimeters a second. And so, I still have to write a manuscript on that. We're really going to have a nice contrast between the two data sets right there. Okay, and then just some statistics, again, relative to the lens definitions. The maximum salinity that we saw in all of the data, 34.8, which is nearly undiluted slope water. That's typically 35. In terms of the climatology from the shelf fleet data, that's normally 33.6. So it was very salty intrusion. The depth was on average about 15 meters. In the climatology, it's 19 meters. The delta S was as large as 1.6. In the climatology, it was 0.46. So again, it was a very strong intrusion, likely because of such proximity to the warm core ring. The long shelf scale is 14 kilometers, vertical scale 10 to 30 meters, onshore penetration distance 33 kilometers, and the total amount of salt in the intrusion in an individual profile was about 5% of the overall salt content in the ambient shelf profile there. So finally, about forcing, and I think this has a lot of ecological significance here. So we saw such strong intrusions because there was a warm core ring offshore, but that wasn't the whole story offshore. It turns out that we actually, one night when the weather was really bad, we usually just use it then to do shipboard ADCP. So we went pretty far south, down to 3930, and used the ship's ADCP. And there was a 40 centimeter a second cross slope flow, and it was 400 meters thick. So there was a counter-rotating cyclonic anti-clockwise eddy that was paired up with the warm core ring. And that's what drove this incredible flow. So it's, I think, a textbook example of how you can transport organisms from the Gulf Stream to the shelf break in a matter of days, probably 3 to 5 days there. Okay, so that's the process view of how the Gulf Stream is interacting with the continental shelf. And that's how things have been, I'll say for 10 to 15 years there. And I'm kind of used to talking to the fishing industry about that. In February and March of this year, I started hearing some really interesting rumblings from the commercial fishing industry. And they were talking about a lot more cold water fish being out there, mackerel in particular. And, they were saying, I remember a report in March that a fisherman from Cape May, New Jersey was saying the species he normally sees were coming in 4 to 5 weeks late there. So we were talking about this all through the spring in our Squid Squad calls, and it came the first week of May, and it was time for me to do an oceanographic update talk, first week of May. And so I was getting all the data together. So this is what I call the Frank bar plot, because Frank developed this plot. So these are monthly averages from each of the 6 boxes across the continental shelf there. And so again, they do have the vertical structure. This is salinity. And so the thing to notice right off is that particularly in zones 4 and 5, you see the yellow and the red, which is up north of 35 PSU there. So you're getting these periodic injections there of the rainwater. You can see all the way up in zone 1 in the very top there that you're actually seeing some salinity signals there. That was a surprise to me that there was some evidence of this getting onshore. So everything looks, really interspersed there up until you get to the middle of 2023. And there's what I call in the in that first week of May, the wall of blue, because it was just all fresh shelf water there. There were no intrusions from pretty much the middle of 2023, well, I'll say August, right on through till, I think Frank ran this, well, it was through May, because I was talking in the first week of May there. But I just thought that this was really interesting. There just, wasn't another period where it was such dark blue for such a long time. And again, I'm hearing all these stories about weird organisms. I should also say, at this point, I'll talk about in a little bit more detail, is first starting to hear the squid aren't showing up. And normally the short fin squid that appear at the shelf break start showing up late April, early May. The catch really picks up in June. So in November of 2023, my student, Lucas Tanzer, actually volunteered to be the co-chief scientist on the student-led cruise on the Neil Armstrong. And this is just a wonderful opportunity for students. The Marine Operations lets students have the ship normally for around 3 days in November, so that we can weed out people that really won't want to be ocean observationalists there. And so they went out and they did 2 cross-shelf CTD transects there, which is the black line there. And they noticed that the conditions were really pretty fresh there. And so Lucas, being very energetic, looked at the NASA SMAP fields there. And so on this plot, the red dashed line that's going across the slope there is what they saw for early November of 2023. And the blue dashed line is like the 10-year average of where the 34.5 exohaline is. And that should be the surface outcrop in the middle of the shelfbreak front. So he gave a talk at our open house in March, and he was talking about this. He had another slide. He actually calculated how much fresh water it would have taken, with the salinity anomaly and the area, and making an estimate of the vertical scale. And it turned out it was 150 cubic kilometers of fresh water would have been needed to actually push that far offshore there. So that got my attention. So that was in March. The person in the office next to mine is Robert Todd, and he runs gliders in the Gulf Stream routinely, and they run from Miami up to Woods Hole. So, I was saying, that Lucas stuff, it really, has me interested in what's happening upstream, particularly because I'm hearing about so many changes in the patterns of fishing. And he said, well, I just had a glider in mid-March that was out there. And so in the left panel is the track of the glider. So he's just bringing it onto the middle of the continental shelf there. The middle panel shows the salinity there out by the north wall of the Gulf Stream. And there is fresh water down to 33 PSU, extending in a 50-meter layer all the way across the continental slope. And this was pretty much of a shocker to me. So essentially the offshore extent had doubled since November there. So, at this point, I was really starting to think about this as a really significant advective event from the north. And so I went back to Avijit. He's in the squid squad. So, we were talking about all this as this was going on. And so Vijay around that time did his final accounting of warm core rings in 2023. And lo and behold, there were only 18 warm core rings formed in 2023. The last time there were only 18 warm core rings formed was 1995. So there's a little bit of a chicken and an egg here about, is the lack of rings, is that, allowing the cold fresh water to come down? We have a lot of questions about what caused this, but I think it's a very interesting part of the story ecologically that there were not a number of rings. And the thing that was really significant in 2023 in the second half was that were not big rings that could carry the water all the way to the shelf break there. They tended to be smaller, they were shorter lived, and they were frequently reabsorbed by the Gulf Stream within 2 to 3 weeks. So we were in the middle of May, and we were in a squid squad call, and every week Kim Hyde and Sarah Salua show this type of figure here. And so SST is in the top left, surface chlorophyll top right, SST anomaly bottom left, chlorophyll A anomaly bottom right. And this kind of put the whole picture together in my mind in the lower left panel, which is the temperature anomaly. So you can see the purple color there over almost the entire continental slope. The mid purple shade is 3 degrees centigrade colder than the 30-year average. The dark purple is 5 degrees centigrade than the 30-year average, which is 9 degrees Fahrenheit there. That's just a huge anomaly. And the thing about this image was just the whole spatial coherence of it. It really was the entire slope region covered with this water mass. By complete coincidence, in the first week of June, Magdalene Andres had to recover some inverted echo sounders off of Cape Hatteras there that she deployed. And she was bringing along a few students, and being a very warm, inviting person, she then invited more students and more students. And she realized that she couldn't handle all of them for the cruise and do her observational work. So she said, "Glenn, are you free for a week? Would you like to be a student wrangler?" And I said, why, yes, I would. And so I contributed to the joyful chaos in the science party by inviting 2 people, an oceanographic instrument salesperson, Susie Crow, and then also a nautical archaeologist there, which was just an absolute joy to have Lindsay on the cruise. She's working as a technician at the Coastal Studies Institute down part of East Carolina University right now. But we had more Bronze Age trade route discussions than I've ever had on any other cruise there. So it was really, really fun. So we went from Morehead City on up back to Woods Hole. And Magdalena took 2 days, and I think she worked 48 straight hours recovering and turning around inverted echo sounders. And then she said, "Okay, Glenn, you and the students take over." So Elena Perez and Lily Enders then essentially worked with me on the adaptive sampling. My role was basically to say, "Great plan," and encourage them. But there were 2 things that we were doing. So one of them was crossing that Gulf Stream shingle right there. And we were looking for squid because the first week in June, I was getting these frantic texts from fishing company owners, "We're not seeing squid, where are they? If you're going to be out there, let us know." So I'll show 2 vertical profiles where those 2 stars are, and then I'll show a shelf profile. And so again, this is from June 6th to 11th. This is the CTD profile in the shingle there. So the red arrow is what I expected the surface salinity to be, which is 36. It's supposed to be Gulf Stream water. It was 33.5. So it confirmed in my mind that this whole temperature anomaly was tied in also to, a big salinity anomaly. And I want to say the thermosalinograph completely confirms that. But the top 25 meters there under 34, so it would be defined as shelf water. Not till you get down to 100 meters is there 36 PSU water. The other profile, which is more in the slope water, so not in an immediate Gulf Stream influence there, that had 32.5 for the surface salinity. So that's even on inner half of the continental shelf for salinity there. And then finally, again, just in terms of ecology, the bottom temperature was 6.2 degrees C first week of June. The year before it was 11 degrees C. So we had a 5 degrees C year-to-year difference in bottom temperature. Let's see, doing here. So now I could go back and actually look at the shelf fleet data. And so Frank Barr and I sat down, and Frank updated the monthly averages there. And so this plot here shows the salinity in zone 2, which is about 50 meters there. That's in fathoms there. And you can see the different years are color coded. And I just want to point out, this is 2024 in terms of salinity here. You can see how much fresher it is going all the way back to 2015 there. We were seeing some individual profiles in June, I think it was, that were as low as 29 off of Rhode Island, which I just haven't seen before. And then in June, also you can see that 2024, was by far the freshest there. So now in terms of density there, we can see that even though it's colder there, the surface densities are the lowest it's been in that time frame there too, by a pretty significant amount, like half a sigma theta unit right there. And the one thing every time I give this talk, I always kind of kick myself because I want to do the n-squared calculation for the different months. I still haven't done that, but I'll do it. Okay, so the timing of the pulse. So again, Lucas is pretty energetic there. So what he did was made a Hogmuller plot along 71 degrees west, which is where he took that CTD line in November. And so just look at the middle panel, because that's actually the salinity anomalies there. So it turns out there were two real pulses to this. So the first one was in late August of 2023 right there. And it was centered on the shelf break. And I think that this is really, really interesting, because from a circulation standpoint, that's exactly where you would expect to see the first signal from signals from the north, because of the shelf break jet. Yeah. And you could actually see it in SST images in the time period. There's a tongue with a local temperature minimum running down in that time period. But I think it's also interesting that in late April, early May there was a second pulse that came in, but it was primarily over the continental slope there. So there's really interesting issues in timing. I'm certainly hoping to have more conversations about this afternoon, about implications for the ecosystem during this time period. But I found this plot to be very instructive in terms of timing. I do want to say there's already been a paper out, Nick Record and Andy Pershing there in oceanography. It is one figure. And the TS diagram there, I'm making no comment on that, just like the fact. But the TS diagram is from 250 meters depth, whereas we were seeing the signal, really heavily concentrated at the surface there. So what might have caused this? Jamie Poulter and a student, Afonso Gonçalves Neto, who had a paper out in 2021 that showed that in 2008, the Gulf Stream took a northward shift near the tail of the Grand Banks. And that led to a lot more recirculation of Labrador slope water. And, we are inferring from the downstream conditions that something must have happened at the tail of the Grand Bank to change this, to allow more of the Labrador water through. So I now call the tail of the Grand Banks the anti-Las Vegas, because what happens there doesn't stay there. Okay, in terms of fishing and ecosystem impacts, squid were absolutely absolutely affected by this. Basically, there was only a very small short fin squid catch, and it was concentrated way down near Cape Hatteras and up to about Chesapeake Bay. That's similar to the pattern of the catches before 2017 there. In 2017, the catch shifted to south of New England. So there's been some real flip-flopping with short fin squid. The long fin squid didn't appear till mid-August, and it was south of Hudson Canyon at the shelfbreak. It should be in June and July near the Cape and Islands there. So that's just, again, an enormous shift. As I mentioned earlier, we were hearing in March from a fisherman in Cape May, multiple species appearing 4 to 5 weeks late, and even the fishermen attributed it to colder conditions. An interesting developing story is mackerel. It turns out that there were huge amounts of mackerel, and in fact, they had to go back and talk to retired fishermen who fished 30 years ago to hear about what they call carpets of mackerels, just really thick layers of mackerel. I talked to Bill Bright down in Cape May, and he said he went over a school of mackerel 6 miles long, and he didn't have a permit for mackerel there. Say whales, and this is from Josh Cohen, so this is anecdotal whale stuff. I'm not making any pretense about being quantitative here, but Josh told me that they've seen a fair number of say whales off New Jersey for the first time in 10 years. It's been a poor year for deep sea scallops. I was at a meeting 2 weeks ago, and I saw a graph, and it was confirmed. The revenue from sea scallops went from 800 million a year 5 to 6 years ago to 300 million a year last year. That's a 500 million a year shortfall, $500 million. That's what these changes are doing. And as a result, not surprisingly, there's a lot of financial distress in the fishing industry. Okay, so this is my add-on to the talk since July and the state of the science. So I was given this talk in Chatham to the Cape Cod Commercial Fishermen's Alliance. And I thought to myself, oh my goodness, well, they've got that flow down from the Gulf of Maine. So I really should do something about the Gulf of Maine. So I should look at Nearacus mooring. So this is the night before I'm giving the talk. And so I got out the data from the B1 mooring there. And that's like a 20-year time series there. So they've got salinity at 1 meter, 20 meters, and 50 meters. And I was kind of surprised about this. The plot on the left is the salinity near the surface. And so the blue line there is the 23-year average. The yellow envelope is the entire range in 23 years for that day of the year. The dots there, the kind of reddish dots, that's 2024. It was 3.5 PSU fresher than the 23-year average. And the tick marks there are actually 2 PSU right there. So they were over 2 PSU fresher than any record in the past 23 years there. I was just astounded that it was this large of a signal. At 50 meters depth, which is the panel to the right, it was still below the 23-year range, but it just wasn't quite as large there. I think it was like 1.5 PSUs. So it was definitely a much stronger signal at the surface. And the other thing that's interesting is this persisted for months. We can actually see that it actually came back to cross on the line right about early July. It got back to normal conditions in early July there. So I do think of it as a pulse now and not a decadal shift, although, everything remains to be seen there. So to wrap up, we successfully mapped a mid-depth salinity maximum in June of 2021 using a variety of techniques. The intrusion was associated with a warm core ring and particularly strong cross slope motions. And we got to see what happens when you don't have these intrusions in 2023, 2024, when we go back to a northern dominated shelf system there. And again, it's just been remarkable to talk to the fishing industry because they have to go back 20 to 30 years to get what they think of as comparable conditions there. And finally, I just want to say two of the species to think about in terms of loss and gain are squid and mackerel there. And I'll just stop there.
Our first two questions are mutual.
Hi, I'm Rachel. I'm relatively new to this ocean stuff, so I don't know. But do you need to re-explain the causes of the intrusion? Is there any anthropogenic impact that
That's a great question. And this is where, oh yeah, is there any anthropogenic aspect to the signal on this? Am I interpreting that correctly? So this is a really complicated question in the coastal ocean. And it's also, affecting how we interpret the Gulf Stream oceans as well there too, because I frequently get asked that. And I've done, a fair number of media interviews and things like that. And I would say there's no direct evidence of a direct influence there. And where it can come in is if it's changing the wind stress curl patterns in the Labrador Sea. And so if it's coming in an anthropogenic manner to the upstream atmospheric forcing conditions. And one of the things that my postdoc Adrian Silver has just kind of tapped me and reminded me a number of times is that there was a paper that said that wind stress curl near the tail of the Grand Banks is an important part of the signal. I am a humble, shallow coastal oceanographer. So these are deeper questions that I leave to some of my more esteemed colleagues. But I'm hoping that if we can talk about these downstream conditions, that it can bring more focused attention on what are the the conditions that give these kind of shifts, because where were the predictions from the numerical models? People are running a lot of numerical models and nobody was running into my office saying, Glenn, 5 degrees C cold. And just to, throw open the controversy door here, what does this mean about AMOC if you're putting in 150 cubic kilometers of fresh water? I still have to do the back of the envelope calculation for May. It was probably double the delta S and double the area there. So that would be 600 cubic kilometers there. Someday I'm going to have to calculate how many Olympic sized swimming pools that is.
Maddie?
Hi, thank you for your talk. Super engaging. And a lot of us in this room are taking our first physical oceanography class. So it's really interesting to kind of tie those concepts and actually look at something that's very applicable. So I guess I have two questions that are less kind of like empirical and more so about like science communication.
Wonderful, wonderful.
The first one being about your involvement and engaging with like fisheries and fishermen, which I think is really cool, given the importance of science communication in today's climate. So I guess it seems like fishermen and fisheries are pretty receptive to the information that you've been communicating to them, given that they've been using like those CTV profiles to figure out where to fish. And so I was just curious, like in general, how receptive these stakeholders are when you engage with them, when you're trying to communicate this information.
So there's a full spectrum. And I tend to work with the people who are probably better capitalized. They're probably more successful fishermen. They're more open to ideas. A number of them have already been working with NOAA before I started working with them. The guy who threatened to come up and board our ship and kill us if we went over his lungfish lines, probably him, not so much. We were getting ready to put up a defensive position in the electronics lab. But You know, it's so funny. I can answer that with an actual anecdote from the president of the Commercial Fisheries Research Foundation. So I brought a filmmaker over, and Fred Matera is the guy, and actually he's the one that said there's more Gulf Stream water on the shelf. So he's being interviewed by this woman, and he said, you know, we really hit a critical point because the guy started to notice that the fishermen who talked to scientists were catching more fish. More money in their wallet, and everything changed. And I thought, wow, that's a good motivation. I never thought of that one when we were writing the proposal. But you know, there's all sorts of different degrees of receptivity. And the other thing that's fascinating is temperature and salinity are relatively neutral things to talk about. I'm not dumping 60 tons of a toxic material into the ocean. And so, you know, there's different things that people are doing to the ocean environment, and that involves a whole different level.
And then, kind of a related question, but do you see like the occurrence of this cold fresh pulse maybe used as like a counter argument to climate change?
Oh, yes. Oh, yes. And I have to tell you, you know, I get placed in some pretty difficult positions with questions. So I visited Chatham in late August, and the president of the Cape Cod Commercial Fishermen's Alliance, John Popular, he was the head of the New England Fisheries Management Council for 10 years. So he knows, he's been inside the sausage factory. So I'm showing him this talk, and we spent 2 hours talking about the PowerPoint, and we spent 1 whole hour talking about what could be done to change fisheries management to get towards ecosystem-based management. So we're 2 hours and 15 minutes into our discussion, and he says to me, so Glenn, you know, you've shown me this. What's the future going to be? And that's the toughest question from the fishing industry. So I said, John, you know, from what I know right now in late August, there's 3 possibilities. So I didn't show it, but the work that John Loader did on decadal shifts, the 3 to 5 degrees C is entirely of that magnitude. So from the warm 50s to the cold 60s to the warm 70s, I said it's possible we've got a decadal shift. I even said that at 1 or 2 meetings with the fishing industry. I said it's possible this is a one-time pulse. And number 3, it's possible that there's a long-term permanent change in the circulation in the Labrador Sea on the continental shelf. And I just talked to someone who was just up there, and I don't even want to think about that one. And I've been able, and partially because of those near cruise moorings, to say this looks like it was a 12-month pulse. So that begs the question, what caused it? Because how frequent is this going to occur in the future? And it's just such a vast amount of fresh water. And, you know, a lot of the climate models, the ones that are, you know, generating all the hysteria headlines there, they're not even resolving processes on the scales there. So, you know, it's a very fraught time with communications because it's easy to generate hysteria, you know, and so, you know, there's a cautious, you know, balance there. And so I was in a video documentary a few years ago on one of our cruises, and I got asked the question, you know, okay, stare out to sea and say something profound about that. I'm used to that question now. And I said, it's a matter of concern, but not despair.
Maybe I'll-
I want to do, okay, good.
You both get
Duke it out.
One of the early slides you showed was this big change in the number of water rings that were being shared. That went from 18 per year to what, 34?
33, yeah.
So what are the Gulf Stream guys saying about that? And associated with that, are there any measurements, say, in the Straits of Florida, when the Gulf Stream is coming up from out of the Gulf of Mexico? Is the actual transport there fluctuating? And is there you know, people wonder about, is the Gulf Stream dying, but is it pulsating somehow? And is anybody measuring that?
Yes, so that is a fantastic question.
Well, thank you.
I can't answer it, of course, but but what I will say is that we've been looking at the conditions of the Gulf Stream interannual variability and, particularly variations in relative vorticity and things like that. We have not been able to figure out a simple explanation for it. So the one thing we have looked at carefully that we can rule out is wind stress curve. So there was a paper that just appeared from Ian Giffords from his master's thesis. And he looked at the variations in wind stress curl over the whole continental slope, and there's just not any big signal for 2000. What he did find was that the wind stress curl gives a very slow net upwelling that can account for up to 25% of the nutrients getting to the euphotic zone over the slope. So the wind stress curl is important, but it just doesn't seem to be, enough to trigger that. We have several PhD students who are working on very hard on their thesis proposals right now, and that's one of the issues that they want to address. I can't answer it, but I'm hoping they can in 3 years.
I mean, years ago, there were measurements like the Florida's.
Oh, yeah, and
In a pretty simple way of measuring transport.
oh, they're still doing that. And what's amazing, Chris Pykuch has been using a lot of that data. And he's been using it in the context of sea level rise, but nobody has looked at Florida stress transport yet. That's an excellent suggestion. I will definitely mention that to people.
This might be a related question, but what would like to, you're looking at this, in what I would think is a very microscopic way. But what would like to figure out whether there are things that have been measured and are known over the last 100 years, like where the Gulf Stream is, rate of transport, temperature. Is there sort of a catalog of things you could measure that you might make predictions about whether fish scallops might be more abundant, et cetera, over a long period of time? Because there are fisheries data, certainly over the last 75 years at least.
Oh, absolutely. So that also is a great question and broadens the aperture a little bit. So one of the things we've talked about in the Squid Squad is we've had several different people working on different oceanographic time series. So we've got the time series of how many warm core rings formed. Adrian Silver, for a PhD thesis, created a heat map of the percentage of time in each month that there's rainwater occupying specific lat long grid there. Adrian also has, from the 30-year Ecomon data, the location and time of all the salinity max intrusions. Another person that works with Chris Pykuch, Carolina Nobre, she has a time series of shelfbreak jet transport. And one of the things we've talked about is creating a master oceanographic timeline out of all this. And then, start to add ecological timelines to it.
I guess I'm thinking there might even be simpler ones, like measures of wind stress, things like that, that are meteorological.
Oh,
where
absolutely.
we know we have
Wind
a lot of
stress
data over
curl,
long
yes.
periods of time.
And then also, my student Lucas Tanzer, the first chapter of his PhD thesis, he compiled all the storms over the 7 years of the Pioneer Array and the impacts on stratification as well. So we've got a storm timeline on there. And actually, I was sitting next to a scallop fisherman, and he said, the thing we really haven't looked at is storms yet. For our big bonanza years for scallops there. Nobody, he said, I think the timing of storms in the fall is really, really critical. And so that's something I plan to follow up with him on. But that's a great suggestion, and it's something we definitely do want to follow up on, especially if we have money. Yes.
I'm a very non-specialist in either of these areas, but I've been listening to the radio up on Cape Cod over the last summer. And their fishery report, which mostly focused on Cape Cod Bay, has suggested that things have been very odd this year. Everything has been late. And I wondered if you had any comments on how Cape Cod Bay was impacted.
Well,
Are they talking to these?
Yeah, I think it was, very late, entirely consistent, because, it's an advective pathway. So there's a Gulf of Maine branch, and then there's what I call the Shelfbreak Express, if you can cut across the Northeast Channel. So a very interesting thing happened around late August, September. Is that there were two warm core rings that interacted with each other. And the New England Aquarium has a project with the Center for Coastal Studies in Provincetown. And it's called the Gulf Stream Orphan Project. And it's a citizen science thing where people send photographs of weird creatures in, and then they compile when and where. They set a record in September for the number of Gulf Stream orphans that they've seen. So Cape Cod Bay went from, I think, a very cold northern, perhaps nutrient rich, although I'm speculating there, a regime into all of a sudden, like how are these creatures getting from the shelf break, like south of Georges Bank or Nantucket Shoals? And in late fall, I think there is a northward flow through the Great South Channel. And I think a lot of them probably went up through that. You know, but it's something I'm definitely following with interest. I'm hoping to go to the Center for Coastal Studies and talk to them about some of this too.
We've been getting a lot of big turtles and things like that.
Yeah,
Strange.
yeah, that's right. This time of year, isn't that when they get all the thermal shock and they get flown back to Florida?
I want to get this.
Economy class.
I think there was one more question.
Hi, I'm Rachel Sizak. I manage the fisheries for DEC, so summer flounders, scallop, bass, all that stuff. And I'm trying to connect a lot of dots here. We've been doing research with Oceanographic Variability, and we've been looking specifically at these like tidal shifts and the effect of greater climate patterns on regional aggregations of fish. And like we knew, or at least we suspected, that 2024 was going to be this really weird year because they were predicting that we would be shifting from El Nino to La Nina. But then like all the climate scientists were like, well, where's La Nina? When is that happening? And it kept like pushing. So we're in this like weird shift. But then all of our monitoring surveys did show that this year was like just the weirdest year. We hardly saw any scub. I saw more spot than I've ever seen in like my life. So I'm just kind of wondering about how this all because it seems to just all be tying together, that these trade winds and the Gulf Stream are really driving these things. And like my brain is going to, okay, the aggregations of plankton that these things feed on, and you know, we're having all these issues with striped bass. And I'm just wondering if you guys are doing this like big picture connecting dots and what your thoughts are there.
Well, first of all, that's exactly why I wanted to come here and speak, you know, to be really honest, because there's so many dots to collect. I've put together, and it's so complicated. I think we need to have many different perspectives on this. So black sea bass, I was hearing from the Cape Cod fishermen, they haven't seen it, and you know, it's been.
We have, so we only have like finalized, like January through like midsummer numbers. And when I tell you that they are just so far below anything we've seen the past decade, which is strange, right? Because their biomass is just steadily increasing, and you have all these things. I'm sure the population is shifting, but it's just very weird that, yeah, nobody was seeing black sea bass. Well, not
Yeah, no, but I think it's entirely consistent with all the other changes. And what I would say is the first cut is just the temperature differences there. And I think that that's what delayed everything a great deal. I think that the second level is probably the nutrient content of that cold, fresh water there. So some kind of nitrate TS relationship for 2024 as it compares to other years. And I'm not a nutrient person, but I did see a plot from LTER in the first week of May, and when Heidi Sosek was out there on their LTER line along 71 West, where the Pioneer rig was, I was pretty surprised because they had an optical nitrate sensor and they had it on a towed vehicle. And I think, you know, a 0.1, 0.3 micromolar, and you know, the middle of the water column, it was 6 to 8. Yeah, so I was kind of surprised. So I actually asked, you know, was there something weird? Did someone like accidentally attach an industrial strength magnet or something like that? And they said, well, you know, it might change by 20%. We know we still haven't post calibrated. But that was just stunning to me how high it was. You know, and I just think that there was just a lot more food because it was, you know, cold fresh, and that's consistent with talking to Leslie now into whale. The body image.
All right, we're almost finished. Christopher, do you want to ask the last?
Sure.
I know I was up for a long time.
Sort of a narrower question. You know, but when you were talking about the presence of the fresh water over the slope and the decrease in the warm core rings, you suggested that there was a chicken and egg problem, and that maybe the warm core rings the lack of warm core rings are causing presence of fresh water.
For allowing, yeah.
Yeah, but a lot of the other things you pointed to suggest that it's mostly upstream.
Yeah.
And so is it fair to say that your view is that probably there's upstream things happening, and that for some reason that's suppressing ring formation?
Yes, I think that working on a hypothesis, and there's a student that wants to look at that, the buoyancy inputs into the Gulf Stream there. I think that that's absolutely a logical interpretation of what I was saying.
It's just a question of why it's suppressing.
I know.
So it's a pushy one.
So. It's just so weird because we were in such a Gulf Stream variability dominated, and then the variability decreased, but it was at the same time as the cold fresh pulse came down. So, and this is where timing is so critical. Timing is going to really help figure out, you know, and even a month or two difference could be critical of determining. Well, thank you so much. I really appreciate it.